Do your code bases get messy, hard to maintain, or full of bugs? What if I told you there's a 5-step blueprint that top developers use to write clean, scalable, and bug-free code? Today, I'll break down the solid principles, not just theory, but real code examples too. Let's dive in. So first of all, let's see single responsibility principle. So single responsibility principle states that one class should only be responsible for doing one thing. So let's see what this means. So let's say I have a class called user service. So user service, and I have several functionalities. Like first functionality can be for creating a user, create user, and another functionality can be API calling. Another functionality can be database fetching. Now, if I have so many functionalities and if I tie all these functionalities to a single class, then this violates single responsibility principle. So if I have a class, then this class should only be responsible for doing one thing. So if the class is user service, then maybe the class should only handle user specific functionalities like creating user, fetching user from database, updating user, and so on. So the idea here is that if I have a class, then the major functionality should only be one. So let us see what I mean by this. So inside Visual Studio Code, let me create a new file called single responsibility principle.ts. First of all, let me paste a bad code, and from that bad code, I'm going to explain what the problem is. So I have a class called user service, and inside this class, I have functionalities like create user and send welcome email. Now, as I said, this violates single responsibility principle because user service should only be responsible for doing one important thing. So maybe it should be only creating a new user, and for sending a welcome email, I should create a separate class for sending email. So to convert this into a code that does not violate single responsibility principle, what we can do is, first of all, let us comment this code and let us transform this code that follows single responsibility principle. So I can create a class called user repository, and this class should only be responsible for creating user. So create user. So user any, and let's console.log out. So console.log, and I can do creating user. And similarly, for implementing this send welcome email method, I can create a separate class. So class email service, and I can implement that method. So send welcome email, and user can be type of any, and let us also console.log out. Email sent. So now if I have to add functionalities for user, I will add in this class. And if I have to add functionalities related to email, I'll add to this class. So user repository class will be responsible for user specific functionalities. And similarly, email service class will be responsible for email specific functionalities. Now let us implement this classes. So I can create let's say I want to create a new user. So to create a new user, I can do const user repository, and I can create an object of user repository class. And from that, I can implement this create user. And let's pass a very simple object called name, and let's say X. So as soon as I do this, let us change the file name in package.json. So the file name is srp.ts, and let us start this by doing npm run start. So creating user. Now in this way, we have converted this bad code to a good code that follows single responsibility principle. Now second principle is open closed principle. Open closed principle states that any class should be open for extension but closed for modification. And so let's see what open closed principle means. So let's say I have a class called payment processor. So payment processor, and in my application, I can have different payment methods. So one method can be through PayPal. And another method can be through, let's say, Stripe. Now in future, if I have a requirement that I need to add a new payment method that is like, let's say, X. So if I have to add a new payment method called X, in this scenario, the problem is that I need to keep on modifying this payment processor class. So let's say I need to add another payment method Y. I need to again modify this payment processor class. So the problem here is that I have to keep on changing this class, and this can introduce new bugs. Maybe the code that I've already tested, now I'm again changing the code, and that can introduce new bugs. So open close principle says that instead of modifying the class again and again, if we have a new requirement, then we can extend the class. So we can extend the class and then we can add new payment methods. So let's see what I mean by this in code. So let us create a new file called ocp.ts, and quickly in our package.json, let us do ocp.ts. So let me paste a bad code example first. So this is a bad code example. So here, payment processor class, and inside this there is a process payment method which accepts a type, and if type is PayPal, then certain PayPal logic will run, and if the type is Stripe, then certain logics will run. Now in future, if I have to add a new, let's say, new type called X, then I have to again keep on modifying this class. And again, if I have to add Y payment method, I have to again modify this class, which is a bad practice, and this violates open closed principle. So instead of modifying this payment processor class, we can extend this class to add new requirements. So how can we do that? So let us comment this out, and now let us transform this bad code into a good code that follows open closed principle. So you can see that there are different payment methods. So what we can do is we can create an interface for payment method. So interface payment method, and we can add a method called process. So now whichever class that implements this interface should mandatorily implement this method. So in this way, so let's say I want to add a new payment method called PayPal. So what I can do is I can create a new class called PayPal, and this PayPal will implement the payment method that we created, and it should mandatorily now implement this process method. So process, and we can add the PayPal processing logic right here. So let's say processing PayPal for now. And similarly, if I want to add another payment method, I can simply create a new class by saying, let's say Stripe, and I have to implement the payment method, and I can write a logic for that specific payment method. Now here, let us create a base class, payment processor, that will use this payment method interface. So class payment method, and let us add a process payment method, and which should take payment as an argument, which is going to be of type this interface. So payment method, and we can call the respective process method for whatever the payment method that is being passed to this object. So in this way, now let us, why this is showing squiggly line? Okay, it says we are never using this. So okay, so now let us implement one of these payment methods. So let's say I want to process PayPal. So to do that, I can create an object for this payment method class. So payment method, so const payment method equals to new payment method. So we have created an object, and inside this I need to call the process payment method, and I need to pass an object of, let's say, PayPal. And okay, the name should be payment processor. Sorry for the typo. And this should be the object of payment processor class. Now, since we have passed payment PayPal object, so this should run this logic. So let us do npm run start. So npm run start and processing payment. So we can see that in future, if I need to add a new payment method, then I can simply create an individual class, implement this payment method, and pass the object in this process payment method, and I can run that payment method. So in this way, I'm not changing this payment processor class again and again. So by this, I am not violating open closed principle. Now let's look at Liskov's substitution principle, which is the third principle of solid principle. Objects of a superclass should be replaceable with objects of its subclasses without breaking the functionality of the program. So what this means is that I have a class which is a parent class. Let's say the class is bird, and I create a new class called penguin. And let's say this penguin is child class of bird parent class. Now what Liskov's substitution principle says is that the child class should match the expectation of its parent class. So if bird represents flying bird, then its child class should also be a flying bird. But in this case, if penguins cannot fly, so it does not match the expectation of its parent class. And this violates Liskov's substitution principle. Let's see what I mean by this in code. So let us create a new file called Liskov substitution principle.ts. And quickly, as usual, let us modify the package.json, Liskov substitution principle. And now let me paste a bad code example first. So this is a bad code example. Why this is a bad code example? Because we have a class which is a parent class bird, and this has a method called fly. And if I create a subclass of bird, which is penguin extends bird, then if I have to implement this method fly, but this should throw an error because penguins cannot fly. So this does not follow Liskov substitution principle. Instead of this, what we can do is, so now let us transform this bad code into a good code. So the aim is that we want to create a subclass that does not violate the expectation of the parent class. So let us create a class called bird, and let us not add any methods or fields to this bird class. And let us create a new class that implements or extends this bird class. So let us create a child class called flying bird, and this extends bird. And let us create a method called fly, and obviously this is a flying bird, so let us console log out flying. So we have created a child class of bird class, which is a flying bird. Now if I want to implement if I want to create a child class for whichever the bird is a flying bird, then I can directly create a child class and make flying bird as the parent class. And if I want to create penguin, then instead of making flying bird as its parent class, I can make bird as its parent class. Let's see what I meant to say. So if I have a class called penguin, and I can, instead of making it a flying bird, I can make this as bird. So bird can be flying bird or non-flying bird. So I can create a method called swim, and I can console.log swimming. So now this does not violate Liskov's substitution principle. Every subclass or parent class has its own expectations, and the child class matches the expectation of the parent class. And in this way, we have transformed bad code into a good code that follows Liskov's substitution principle. Now the fourth principle is interface segregation principle. Now interface segregation principle states that clients should not be forced to depend upon interface they do not use. So this is the example. Classes that implement small interface are more focused and tend to have a single purpose. Let us see what this means. Let's say I have an interface called worker, and inside worker there are several methods like work and another method called eat. Now if I have to create a class that implements this interface, so let's say I have a class called robot, and now if this class implements this interface, then this class should compulsorily implement these two methods. Now, if robot does not need these two methods, then this will be a problem. So this violates interface segregation principle. So to solve this, what we can do is we can divide this interface into smaller parts. So we can create a separate interface that implements work method. So we can create an interface called workable. So what I mean to say is we can create a separate method or separate interface called workable, and that has the method work. And similarly, we can create separate interface that has method eat. Now, if the robot wants to implement only work, then it can implement only this interface and not this interface. And let's suppose there is a class called human, then it can implement both of this interface. So by dividing our big interface into smaller interface, we are not violating interface segregation principle. So let us see this in code. So let us create a file called ISP, interface segregation principle.typescript, and inside package.principle or package.json. So let us create isp.ts. So first of all, as always, I'm going to show you a bad code example. So here is an interface called worker, which has two methods, work and eat. Now robot has to compulsorily implement work and eat. It does not need eat method, but it has to implement the method because it is implementing this interface. So let us convert this bad code into a good code. So let us comment this code. So commenting this code now. So let us transform this code into good code that follows interface segregation principle. So I can create a separate interface called workable, and this interface has only one method, work. And similarly, I can create a new interface called eatable, and eatable has method eat. So if any class like robot only needs to implement work method, then it can implement workable interface. So robot implements workable, and I can implement this work, and I can just console.log working. And let's say I have a class called human, then it can implement both work and eat method by implementing both workable and eatable interface. So let's say the class is human. Now it can implement workable as well as eatable. Now I have to also implement the eat method, and I could do console.log eating. So in this way, we have transformed our bad code into good code by following interface segregation principle. So the final principle is dependency inversion principle. It says that high-level modules should not depend on low-level modules. In fact, both of these should depend on abstractions. So let us directly code this and understand. So I'm going to create a new file called dip.ts. First of all, let me paste a bad code example as always. So I have a class which is a low-level module called MySQL database, and there is a method called save, and we are console.logging a very basic message, and there is also a class called user service, and now this creates a new object of this class, and here we have a method called save user which takes in a user object, or user which is a string, and then this calls this method in the db class. So basically this violates dependency inversion principle because this class is a high level module and this class is a low level module. Now currently my high level module depends on low level modules, and what dependency inversion principle states is that high level modules should not depend on low level modules, and both of these modules should only depend on abstractions. So currently my high level module is depending on low level module because my high level module is directly tied up to this low level module. Now in future, if my SQL database changes or I need to add a new database, then I should keep on changing this user service, which obviously violates open close principle. But most importantly, this also violates dependency inversion principle. So how can I solve this? The solution is that I need to create abstraction, and both my high level module and low level module should depend on abstraction. So let us transform this bad code into a good code which follows dependency inversion principle. We know that the solution is to create an abstraction. So let me create an interface called database. And let me create a method for this interface and which takes a data which is going to be of type string and returns void. So now I will create a class called MySQL database, which is a low level module, and that low level module will depend on this abstraction. So class MySQL database, and this should implement the database. And let us implement the method also. So console.log saving to database, and let's do data. Okay, so now if I want to add a new database, maybe I need to add a database called MongoDB, then what I can do is, instead of changing this class again and again, I can create a new class called MongoDB, and this will implement this database, and we can do saving to MongoDB, and we can do data. Now I need to take care of my high level module. So to take care of the high level module, I should create the user service class. So class user service, and let us create a constructor. Now constructor will take a private database which is going to be of type database. So database is the interface, and this will be empty. Now I can create a method called save user, which is going to be of type user of type string, and here I can call the save method from DB or database interface. So this db.save, and I can pass user. So take a look. This is my high level module, and my high level module is no more dependent on low level module. In fact, my high level module is dependent on the abstraction, and also my low level modules are dependent on abstraction. So in case if tomorrow I have to add a new database, I can create a separate class, and I can pass the object in user service, and this follows dependency inversion principle. So let me show you the implementation. So I can create a new object of MySQL database, and what I can do this is I can store this object in a variable called MySQL. So const MySQL, and I want to create the object of this class user service. So new user service, and I can store this in the variable user service. So const user service 1, and finally in user service 1, so why this is showing error, new user service. Okay, I have to pass MySQL in the constructor, so MySQL, and what I can do is I can call user service 1, and then I can call save user and pass, let's say, let me console you. And if I run this, so in my package.json, I can do dependency inversion principle, and let's do npm run start. You can see saving to database, let me console you. So we have changed our wrong code or bad code into a good code. High level module and low level module are independent, and in fact both high level module and low level module are dependent on abstraction. So in this way we follow dependency inversion principle. Instead of user service creating its own dependencies, the control is now inverted. External code decides which dependency to inject. In this way we have completed all the 5 principles. Thank you for watching this video. I'll see you in the next one.